Welcome to the 6.3 notes. Today we're going to learn about something called a logarithm. Logarithms are super exciting because we now have a way to do the inverse of an exponent. We can do the inverse of the exponent if we know what it is, like the inverse of a third power is the cube root. But we don't know how to do something like how do we get x by itself in this, or y by itself in this equation. How do we remove something from an exponent, okay? And that's using a logarithm. So if y equals b to the x power is the original function, then the inverse is x equals b to the y power. Kind of like this one, I just made the b a 2 up here. This is the same thing as y equals log base b of x. So that has gotten y all by itself. Now, what is a logarithm, you ask? Good question. So I'm going to use this example right here that I just did to explain it. B is the base. X is sort of like the inside or the answer. A logarithm will always equal the power of the base that gives you what's called the argument, which is this part right here. So the argument is this part, the base is the small number right here. So this is the power of this that gives you this. You are looking for a power. That's what a logarithm is. I'm going to graph y equals 2 to the power of x, and I'm going to put a 1 times out here because this is how we were used to seeing it. 1 is actually going to be your y-intercept, and 2 is the number you multiply by to go to the right. So 1 times 2 is 2. I'm going to go to 2 over 1. 2 times 2 is 4 over 1 more. 4 times 2 is 8. Now I'm going to go over 3 times because I've multiplied by 2 3 times. So this should kind of ring a bell from back in 6.1. I can also divide by 2 as I go to the left. 1 divided by 2 is 1/2. So I'm going to go to 1/2 in the left one instead of right one. So as you go to the right, you're multiplying by this number. As you go to the left, you're dividing by it. And this is an exponential growth equation. It looks something like this. And then what I'm going to do is come over here and write the coordinates of the points I just put on there. So I went left 1, up 1/2. Where x is 0 is my y-intercept, which was at 1. Over 1, up 1. Sorry, up 2. That's this point right here. And I went over 2, up 4. And I went over 3, up to 8. All you have to do to get the inverse or the graph of the logarithm is switch the x and the y. Sorry about that. Sorry, my lights like to be stubborn. And I will give you a second to write this. The table is just flip-flopped. These values are now the x's, these values are now the y's. And if I go to put those on my graph, I'm going to go to over 1/2, down 1. I'm going to go over 1, up 0. So my y-intercept has turned into my x-intercept. I'm going to go right 2, up 1. So I'm just graphing these new points. Over 4, up 2. And over 8, up 3. Like that. So this kind of gets flipped to this. Okay, and then I'm going to go over the domain and range really quick. Domain goes left to right. This graph goes left and right forever. Range is bottom to top. This one doesn't go lower than here at 0, but it goes up to infinity. And here's something we didn't really get a whole lot of time to talk about in the last unit. When you swap x's and y's in the points, you also do that same thing for the domain and range. So now the domain should be 0 to infinity, and the range should be negative infinity to infinity. Which is true because it goes to the left up to 0, but then it goes to the right forever, and it goes down and up forever. So when you switch these x and y values, you're also switching the domain and range. So it switches in points, in the equations, and with the domain and range. And then one last thing before we start going over some real good examples of what a logarithm is sometimes you're going to say something like the log of 3. If there's no little number down here, that is automatically a 10. So log 3 is the same thing as log base 10 of 3. If you don't see that number down there, it's automatically a 10. That's also where the log button in your calculator comes from. It's called the common log, and it has a base of 10. Here's how these examples down here work. It says evaluate without using a calculator. That means don't just type it in and hit enter. What you need to do is remember that the logarithm equals the power of this that gives you this. So 4 to what power equals 64? Well, 4 cubed is 64, so your answer here would be 3. And that's really how all of them work. The next one would be what power of 81, oops, there we go, would give you 9. This one's a little trickier because in order to get between 81 and 9 using a power, not by multiplying or dividing, you would need to do the square root. And what power is the square root, guys? 1/2. So anytime you have to do a square root or make the number smaller like this, that's going to be a fraction exponent. And then the very last one on the top row is probably pretty easy. 5 to what power is 25? 2. So your answer is the power of the base that gives you the number next to it. You're finding the power. And we know these powers because we've done them on the powers table. You are welcome to pull that up and use it, but I will not be giving it on this unit's test because the goal is that we know that a little bit better. So then on D, 32 to what power is 2? Well, we should know now that 2 to the 5th is 32, but we're not starting with 2, we're starting with 32. So in order to go backwards, instead of doing the 5th power, we would need to do the 5th root, which is the 1/5 power. And I don't mind if you take your calculator out to double check what you thought it was. Okay, so 32 to the power of 1/5 is 2, just to prove that I was correct on that. And then here we need a power of 3 that equals 1/27. Well, what power of 3 is 27? 3. In order to make it go to the bottom, it had to have had a negative exponent. So the only time a number goes down to the bottom like that is if it had a negative in the exponent. And then on F, 4 to what power is 1/16? Well, 4 squared is 16, but it's on the bottom, which means the power had to have been -2. Okay, 7 to what power is 7? The first power, guys. If a number doesn't change, it was taken to the first power. And 8 to what power is 1? 0. Anything to the 0 power equals 1. And then this is where that imaginary 10 comes in. 10 to what power is 100? Hopefully you know that 10 squared is 100. And then I'm going to do these bottom 3 with you guys on Zoom, but basically you do this middle part first. 4 to the 4th power.
Can I please have the following students to the office? Adriana Harper, Tristan Hellstad, Clint Sarles, Mason Kane, Elmer Bourne, and Adrian Seals. Thank you.
So 4 to the 4th power is 256. So that's where I'm getting this 4 from. and then you're basically asking yourself 2 to what power is 4 squared.